Good morning to all. Today we are going to discuss about introduction to information theory. So as we all know that information is very important, which is being conveyed from one point to another point, where we used to have most of the information being conveyed over a lot of devices. So as a part of information theory, when we are communicating from source to destination, so the source and destination has to take care of how much amount of information we are being conveying. So in order to know the content information that is being conveyed by the source, so we have to know what is the content of information, or we can say that information content. So the branch of study which deals with information content and amount of information that is being conveyed by the information source is known as information theory. So in this presentation, we are going to see a brief introduction to information theory related to information content and entropy. Then so let us have a brief introduction. As we all know that information is nothing but the information that is being conveyed by the source, which we are willing to transmit from source to the destination. So generally, whenever we are transmitting certain information, so everywhere at the destination point, they will take care that how much amount of information is being conveyed. So as a part of that, let us have an example that suppose we are planning to go for a tour for a particular place which we don't know what is the climatic conditions over there. So then we will ask to a person. So then what? So suppose we are planning to go on in the month of January. So then we will ask for a person that, so what about the climatic conditions over there? So then he may say that, so in the January there may be very snowfall, or it may have a chance of rains. So this type of information that we are being communicating to us, then we can decide that whether that information is correct or not, first point. Then with that information we will decide whether to plan in that particular month to go over there or not. So that is nothing but what is the chance of occurrence of that particular event. So generally if that particular place is like that only, then it is doesn't matter if you go in any month. But if you are having that occurrence will be more only in the month of a particular January or any month, then we need to decide, then it is conveying more information where we need to check once and to go in particular way. So similarly in the information theory also, so we are going to talk about more about the information and content of the information. So here we are going to say that, so basically the information content depends upon information being communicated, that is it depends upon the probability of occurrence rather than the context what we are saying, that is nothing but whether how the chances are there for occurring of that particular event. So that in the case either it may be probability 0 or 1. So we can say that high probability or low probability. In the information theory, we are going to consider the two possible symbols, that is 0 and 1. So information theory, if you want to say a basic definition, information theory is a branch of probability theory which may be applied to the study of communication systems, which will deal the information content analysis in mathematical form. So if you want to calculate the information in physical form, so we are going to deal, or we are going to learn about the information theory. So then, so the majorly we all say that information. So basically the information depends on its probability of occurrence rather than the content. Okay, whatever we are conveying, it doesn't matter. But whatever it happens, whether the probability of information is high or low, based upon that only we are going to design or define the information. And calculating the information content is most important to decide how much amount of information we are being sending from source to a destination. So then coming for so we need to have certain probabilities of information all the time. So the information should be a low probability or high probability, but it should be always a non-negative. So it is nothing but, so we need to keep in mind the information should be a non-negative quantity. So there will not be a negative information at all. So either it may be, in the worst case it may be 0, but it will not be a negative value. So all the time the condition for the information theory or information content is IP should be always less than or equivalent to, greater than or equivalent to 0, but it should not be a negative value. Then if you are going for the two different events which are going to occur simultaneously, then the probability of all the things will be taken as I of, if you are taking two sources with a probability P1 and P2, then the total probability will be P1, I of P1 plus I of P2. So then, so basically the information theory denoted with I of x. That is nothing but we are going to calculate the information with a notation of I of x, and it is completely related to the probability of occurrence of that particular x. So here x we will call it as a source, so that that source may have a multiple or more number of symbols. So based upon the occurrence of all the symbols, so we are going to calculate the information content. Then we need to know, or we need to measure the information content. That is, we have to know a physical value or physical quantity of information. For that, we need to calculate the information content. That is nothing but we will call it as a measure of information, which is nothing but denoted with information content of a symbol. So basically, where there are a lot of mathematical tools that can be used to calculate the information, but here we are going to use the logarithmic measure of information theory, because in the logarithmic only, so we will get an easy manipulations instead of going for a into b, so that can be done with a plus b. Okay, so this is the reason. So if you are going for a by b, so there we will go with a minimum manipulation of a minus b. So as the complex manipulations are simply done with plus and minus, so generally we prefer logarithmic measurement or logarithmic calculations for calculating the information theory. So here also we are going to take the information content, or we can call it as a logarithmic measure of the information. So as we said that information is denoted with I of x, where this x may have a n number of symbols from x1, x2, xn. So that, so it is, I already said that the information content is depending on the probability. That is nothing but inversely proportional. If the chance of occurrence is less, then the information content will be more. If the chance of occurrence is high, the information content will be low. That is nothing but, if we again go with one more example, if suppose we got an information that so tomorrow exam was postponed, so until unless there is a no cause, the exams will not be postponed. But if we feel that information, it is conveying more information, but probability of occurrence is less, so that is nothing but more information being conveyed, the probability of occurrence or chance of happening will be definitely low. So for that sake only, information content is inversely proportional to probability of occurrence of that particular source. And as we are using the logarithmic calculations, we use log. So that is nothing but information content is defined as I of x is equal to log of 1 by p of x. So this x is nothing but entire source. This x consists of set of symbols which may vary from x1, x2 and so on up to xn. So then 1 by x can be denoted with minus. So either we can derive log 1 by p of x or minus log p of x. So then p of x denotes probability and I of x is nothing but the communication information. Then we are having, so we need to know what are the information. Information is, we are going to hear information, we are going to measure. So then it is a physical quantity, or we are going to get a value which it is conveying in the source. So as such, we require some units for information. So as if you are going for minus probability with 0 and 1, okay, where we are going to denote with bits, so it is units will be bits. Okay, if you are going with a base of e, then it will be considered as a nats, and if you are going with a base 10, it is Hartley. But out of these three units, so as in the information content, we will consider, because here the probability is high, it is 1, probability is low, it is 0. So therefore we are going to calculate the information content in terms of probability with either with 0 or 1. So therefore generally in information theory we are preferring the units as bits. So therefore then, so we need to know certain properties of information theory. That properties of information, already we said that the probability will be high, then information will be 0. That is low information, and vice versa. If probability is 0, then information content will be high. That is, if the probability is high, information conveying will be low. If the probability is low, information content will be high. Then all the time the information should be always greater than or equivalent to 0. It will never be a negative information. So we want either the no information will be there or high information will be there, but it will never be a negative information. So then if we are calculating for two source symbols of I and j, if information content is less than the second information source, then obviously the probability will be reverse. If it is greater than, the probability of two sources will be less. And if you want to consider for a mutual information or combine information for two sources, then I of xi comma xj will be information content of source 1 and source 2, where we need to decide that all the information sources are independent. So the symbol should not be dependent on one symbol with the another symbol. So in this information content, we are going to calculate the information content of individual symbol. Then we will combine it to form of an individual source. So these I have made it as a simple examples. Later on you can see the PPT and you can solve it. Then coming for another term called we are knowing in the information theory is entropy. Entropy is called as average information. Now in the earlier topic we have calculated the information source of individual symbol. Then out of all the symbols, so few symbols may convey certain information, few symbols may not convey certain information. At that cases we have to know what is the average information content, and finally how much amount of information we are being conveying to the destination, to the source. That will be calculated with another term called as an entropy. So entropy is nothing but simply we can call it as a average information. Out of all the sources in a, all the symbols in a source, how many number of symbols that are conveying its information is nothing but entropy. It is denoted with capital H. That is nothing but average information that is being conveyed by a message. If the total message consists of 10 symbols, out of 10 symbols, what is the average information being conveyed by the all the 10 symbols is called as entropy. So the entropy is simply given with a relation. Here also information, average information h of x. Then already we know that I of x information is proportional to probability. As it is depending on probability, the average information h also depends on the probability only. So that's why we are having again the entropy relation in terms of probability only. But as it is need to communicate for n number of symbols, we are taking h of x is equal to summation m of I equal to 1. Any number of symbols we are going to take, that will be summation. So probability of that particular symbol and log of pxi. So it's simply we can say that I of xi into pi. So already we know that log of minus, or we put as inversely proportion, but before that we have kept minus. So we can say that simply entropy is nothing but summation of information content of that particular symbol to the probability of that particular symbol. So with this we are going to know the exact average information that is being conveyed by the source information that is being carried from source to the destination. So these are the examples which listed for calculating information and entropy. So we need to calculate what is the individual information content. Then we are going to calculate the total information that is being conveyed in an average amount from source to the destination. So we have a properties for the entropy. All the time, as information should not be a negative value, then the first property is all the time the average information also should be greater than or equivalent to 0. It should never should be a negative value. Then the if entropy is 0 when all the symbols 0 except 1, that is nothing but in n number of symbols. If any one symbol is also 1, so the average information will be 0. Then if you want to calculate for all the symbols, so the normal definition we used to take is log base 2 m. This m is nothing but occurrence of all the symbols in a particular source. Then we have seen information content of individual symbol and average information content of the entire source. Then we need to know the rate of information, that is how much amount of information we are transmitting. That is nothing but how much amount of time that it takes that information to carry from source to the destination. That is denoted with information rate. Then it is defined simply as an average rate at which information is transmitted in a particular time interval. So it is again what is the amount of information we are transmitting, that is nothing but entropy, and how much time it takes to transmit. Then obviously we will get the information rate. So that's why information rate is denoted with R. Simply it is an how much amount of time we are going to take a symbols to transmit an average information. So R into H. So thank you.